4.7 Inverse trig functions. What you should learn: how to evaluate and graph inverse sine functions, how to evaluate and graph other inverse trig functions, evaluate the composition of trig functions. So an inverse sine function is kind of a misnomer. Sine can't have an inverse. It's not a one-to-one function. You can see right here, right? It wouldn't pass a horizontal line test. But we're going to use the fact that you can have an inverse from this point to this point. From here to here, sine has an inverse function. It's on the interval of negative pi over 2 to pi over 2. So if we're looking at like an XY chart, like when we do our graphs here, right? So from 0 to pi over 2, and from 0 to negative pi over 2, sine has an inverse function, right? So that's when we do inverse sine, it can only come between these two things, or like from negative 90 to 90. Because if you look at the graph here, right, other than that, sine doesn't have an inverse. The inverse of sine is called either arcsine or sine inverse. So that's this graph here. So the graph of sine inverse is like any inverse. If you do if you flip it across here, you'll get a sine graph, a sine inverse graph. That's not the thing we're going to focus on in this lesson. We're going to focus on how you evaluate inverse sine. So when you evaluate inverse sine, it can only become between negative pi over 2 and pi over 2, because that's the only time sine has an inverse. So let's do a couple examples like that. So we're going to find arcsine of negative 1/2. So step 1, we're going to draw the sine inverse chart. So draw my little sine inverse chart. Remember, sine inverse only works in quadrant 1 or quadrant 4. 2, we're going to draw a triangle in correct quadrant. So in this case, right, it's a negative, so I have to be on the negative side. Draw a right triangle like we always do. Here's the angle we're trying to find. 3, we're going to use SOHCAHTOA to fill out sides. So this is sine SOHCAHTOA over h, so the opposite should be negative 1, and the hypotenuse should be 2. And then we're going to use 30/60 90 / 45 90 to figure out the angle, to find the angle. So in this case, this is a 30/60 90 triangle, right? Negative 1, 2 is a dead giveaway here, because 1 could be a 45 but the fact that it's 2 not radical 2 is 30/60 90. And then we're opposite the 1, so this is a small angle. This is a 30-degree angle. And then, but we do have to notice that we went down, not up, right? Because remember, sine only goes between up here and down there. So this is a negative 30 degrees is our answer here. If we want radians, remember 30 degrees in radians is pi over 6. So negative pi over 6 is our answer. And that fits, because keep in mind, we could only go between pi over 2 and negative pi over 2. We can't go anything else. So that'll be the value of that arcsine. Now we're going to do the same thing. Now that we know it, we're going to do the same thing for B. We're going to do a little faster. So for B, again, draw it. Sine inverse is going to go here and here. This is a positive one, so it's up here. There's my angle. SOHCAHTOA, so over h. Opposite is radical 3, hypotenuse is 2. This is a 30/60 90 triangle again, but this one now we have the radical 3 is opposite. So that means this is a 60-degree angle. So 60 degrees is my answer, or in radians, pi over 3. So that's the inverse of rad 3 over 2, right? So it's basically saying sine of what angle gets me rad 3 over 2. That's what we're trying to find. Same thing here, right? Sine of what angle gives me negative 1/2. In this case, it was negative pi over 6. Over here is pi over 3, or 60 degrees. C, sine inverse of 2, too big. Not possible. Remember, sine and cosine only go between 1 and negative 1. You can't go any higher or lower than that. So if you're not between 1 and negative 1, you can't find the inverse for sine and cosine. Tan could do anything it wants, but for sine and cosine, you're going to do those. So that's how you find the inverse of sine. Now let's talk about the inverse of other trig functions. So cosine's a little different. Based on the graph of cosine, its inverse function, right? It also doesn't have an inverse, but we could restrict it. It has an inverse between 0 and pi. So cosine, its inverse, goes between 0 and pi. Plus and minus. Right, so cosine's positive in quadrant 1, but cosine's negative in quadrant 2. So you can also see here, right, cosine's positive from 0 to pi over 2, which would be from here to here. Then cosine's negative from pi over 2 to pi. So anytime we do a cosine problem, we're going to use this graph. And then tan is actually like the sine graph. It only works from negative pi over 2 to pi over 2. So tan, very similar to the sine one. You can't find an inverse there, but plus and minus there. So I actually say this is the tan or sine graph, sine inverse graph. So if you're going to do sine inverse or tan inverse, it's this picture, this graph we're going to use. If you're doing cosine inverse, it's this picture. And that all comes from the graphs of sine and cosine. Right? They can only have an inverse unrestricted amount. Okay, so now that we know the inverse graphs, let's do a few more examples. This is just a summary of all arcsine, cosine, and tan and how they work. So the main of them and the range of them. But let's do quick examples. So first we're going to find arc, cosine, and rad 2 over 2. So I'm going to do that over here. So the process, right, we're going to draw a little triangle. So remember, cosine works in quadrant 1 and 2. It doesn't work down here. We are positive, so we're going to be quadrant 1. So ga toa, so a over h. Adjacent is radical 2, and hypotenuse is 2. Now you might say I've never seen that before. I've never seen like a rad 2. This is just 1 over rad 2 rationalized. When you rationalize 1 over 2, you get rad 2 over 2. So the general shortcut is if you see a radical 2 anywhere, it's 45. It's the only time you get it. So this is a 45-degree angle. We want to be in radians probably. So I would say, actually it doesn't say, so we'll say 45 or pi over 4. B, cosine inverse of -1. Oh, that's a little tougher. So we have 0, pi over 2, and pi, again, plus minus, dot, 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 dot. Now, keep in mind, if it's 1 or -1, you're not going to get that from a triangle. And 1 or -1 for sine or cosine, 1, 0, or -1 for sine cosine is on the unit circle. It's a quadrantal angle. So it has to be one of these points. So we have 1, 0, 0, 1, -1, 0. Remember cosine, it's sine e. Cosine is x. So you're looking for the x value where it's -1, and that's at pi. So like that. C, arctan is 0. So that's going to kind of be the same thing. So tan actually could do 1. How remember the rule here says for sine and cosine. Tan could do 1, but tan no one could do 0. So it's actually also going to be on one of these points. But remember, tan inverse and sine inverse look a little different. Right? Tan inverse and sine inverse look like this. So it's either going to be one of these points. This is 1, 0. This is 0, 1 at pi over 2. Negative pi over 2. This is 0, -1. Now think about tan. Tan is sine over cosine. So up here, which is y over x. So look at the point right here. 1 over 0, I'm going to get there. If I put y over x on the point up here, I get undefined. It can't divide by 0, so it's not that one. Look down here, same thing. -1 over 0, undefined. Where does tan equal 0? Right here, 0 over 1. So we're looking for that one. And that happens at 0. So the answer to that one is just 0. The angle 0 is where it happens at. Tan inverse of -1. Right, plus minus. It's a minus, we're down here. Tan can do -1. Tan's the only one I could do 1. So you just put 1 over 1. Make it a fraction, so 1 and 1. Right, tan is TOA, opposite over adjacent. What angle is that? What triangle has 1, 1? 45. So this is a 45-degree angle. Technically, we have to go down, right? So -45 or negative pi over 4. So that's the idea of how you do inverse trig functions by hand, right? So if it's sine or tan, you're gonna do the triangle picture that looks like this: arcsine or tan, right? Plus minus. 0 to pi over 2 to negative pi over 2. If it's arc cosine, which is the same thing as inverse cosine, it looks like this. 0, pi over 2. So that's how you do it by hand. And then once you do that, you make a little triangle in the spot if it requires a triangle. Sometimes it don't. Sometimes they're a unit circle. And you figure out what angle makes that work. So what angle gets you 10 and negative 1. Sometimes you can use a calculator. So let's do this. Let me turn this on. So I have it in radians. Let's keep it in radians. So all we have to do is type into our calculator second tan. So look at tan negative 1, cosine negative 1, sine negative 1. And then type in, what do you see? Negative 8.45, which is negative 1.453. We'll do nearest, we'll approximate it. Same thing with sine inverse. So second sine inverse, type in 0.2447. Again, we're in radians, so maybe the values won't make that much sense to you. But these are just radian values. Arc cosine 2, I'm going to tell you that's not going to work. Right? Remember, sine and cosine go only between negative 1 and 1. So if you hit that one, it's going to say domain error. So error domain. So you can't do that one. So this one's not possible. No solution. Okay. These are the graphs of arcsine and cosine. So if we have these basic pictures in our mind, then it makes graphing like these are the parent functions. So if we have those down in our head, it makes graphing something like this easy because you just have this is just a shift to the right too. So right, cosine goes from negative 1 to 1. So a basic cosine graph goes from negative 1 to 1 all the way up to pi over 2. And it looks kind of like this. All we're going to do is shift it 2 to the right. So now we're going to go from 1 to 3. And it's going to be the exact same picture. All right, this one right here, cosine. This is a horizontal flip. It's on the inside, so we're going to flip it left and right. So instead of looking like this guy, it's going to look like this guy. So, like everything else, if you know the parent function, doing all the translations and flips and stuff is easy after that. Composition of functions. So now we're going to do inverse of composition of functions. Now normally, right, a function and its inverse cancel each other out. You can say, oh, don't cancel each other out. But we do got to watch out for the domains of f and f inverse. The domains of the inside are the ones you have to watch out for. Because not every single time when you do sine and cosine are the domains proper. So it doesn't always just work out. So like they show an example here, where the values actually don't match, where arcsine of sine does not cancel and get you y. That's not always true. They have to fit in the domain of the inside interval. So let's do a couple examples. Like this one, tan of arctan of negative 5. Tan domain is all real numbers. So actually for tan, you don't have to worry about it. These do cancel out. You can just get negative 5. On the next one, that's not the case. Arcsine, like, there's no way to get arcsine. You get 5 pi over 6. Remember, arcsine only works in quadrant 1 and 4. 5 pi over 3 is over here. It is in quadrant 4. If we did 5 pi over 3, like normally 0, pi, 3 over 3, 6 pi over 3. But we can't get there because we have to go 3 over 3, right? 6 over 3, a little less is 5 pi over 3. But we can't go around this because this arcsine doesn't work there. So I can't just cancel these two out and get 5 pi over 3. That would be the wrong answer. What we could do is find a coterminal angle that fits there. Or we could just solve sine of 5 pi over 3 and then arcsine, like kind of do the problem, like inside outside. That would work. You could figure out what this is and then arcsine it. That's a lot of work though. What's usually easier is just to find a coterminal angle. So 5 pi over 3. Let's subtract 2 pi, because remember that's how you find a coterminal angle. Add or subtract 2 pi, or 360. Do a common denominator. So this will be 3 over 3, 3 over 3. And I get 5 pi over 3 minus 6 pi over 3 is negative pi over 3. Does that work? Yeah. Here's 0. You just go down from here to there. That'll get you negative pi over 3. So I could change this to this arcsine of sine of negative pi over 3. And that fits the domain of this guy. So now these just cancel out. So my answer is negative pi over 3. Right? So that's one way to do it. Another way to do it is just if you figured out what sine of pi over 3 is, let me write it again. Another way to do this is just figure out what sine of pi over 3 is. I'll tell you right now, sine of pi over 3 is negative rad 3 over 2. So once you do that, if you figure out sine of pi over 3 is negative rad 3 over 2, then you just have this problem. What's arcsine of negative rad 3 over 2? Well, you draw a triangle right here, negative rad 3, 2. You figure it out, that's a 60-degree angle, so negative pi over 3. So you can do it either way. You can work inside out, or if you notice, like, wait, these should cancel out, but I'm not sure if the domain works, check the domain first, and then it's find a cultural angle that does make it work. X, cosine inverse of pi. Same idea, is like, does this work? Well, cosine inverse, this is tricky because you think you could do it, but actually, remember, cosine inverse only works between 1 and negative 1. Pi is 3.14. This does not work. So already from this, you can't do it. So this is not possible. Because you can't find, like, if you're not sure how to work this, just work inside out, right? Like I could have figured out what arctan of negative 5 was, it would work. Then you find tan of that thing, done. You could do here, sine inverse of this, sine of this, get a value, then do arcsine of that. It would work. This one, if you try to do cosine inverse of pi, like you put that in your calculator, you do it by hand, you're not going to get an answer. It's not possible. This is too big. So this one cannot work. Okay. Find the exact value. So this is actually one of my favorite questions in the world. So for these, they just want you to figure out what tan of this arc cosine is. And the way you do is you build a triangle using inside function. And then you evaluate the outside function. And that's it. I like these because they look hard, but they're actually really easy. So like the first one here. I want to figure out what tan of arc cosine 2/3 is. Okay, well, let's draw arc cosine. Remember, cosine can only have it in quadrant 1 or 2. This is a positive value, so draw in quadrant 1. Draw a little triangle. Here's my theta. Cosine, right? So gatoa, AH. So adjacent is 2, hypotenuse is 3. That's it. You are done with arc cosine. All we gotta do now is figure out what tan of this triangle is. Well, tan is toa, right? It's opposite over adjacent. Well, I don't have the opposite. I gotta find that. So we can do that. So toa. Sorry, Pythagorean theorem. We're gonna do 2 squared plus b squared equals 3 squared. I get 4 plus b squared equals 9. I get b squared equals 5 square root. B equals plus and minus 5. But we're in quadrant 1, so everything's positive. So radical 5. That makes tan toa, opposite over adjacent. So rad 5 over 2. That's our answer. That's all you have to do. So we'll do it again real quick for B. I'm going to build a triangle with that one. Now arcsine is in quadrant 4. So I'm going to draw it down there. Here's my angle. So toa OH. So this is negative 3 and this is 5. This is an easier one. It's a 3, 4, 5 triangle. So this is a 4 automatically. And again, we're done with arcsine. 4 is positive because you're going to the right. We got to figure out what cosine is. So toa. So adjacent over hypotenuse. 4/5. Remember, if you're not sure about the sign, you can also always do all students take calculus. In quadrant 4, cosine is positive, so we should get a positive answer, like we did. Last one. So these are the same ideas, is that now we're going to have an algebraic expression. We have 3x there. And that they actually both deal with arc cosine, so I'm just going to draw one big triangle. And normally, arc cosine, right, you do this and draw in the proper quadrant. There's an x, there's not really a proper quadrant, so I'm just going to draw a triangle here. Like that. I actually don't even need the rest of it. So here's my theta. It is cosine, so toa. You're like, wait, it's only 3x. Put it over 1 as always. So adjacent to 3x, hypotenuse is 1. And that's it for our cosine. That's it for the inside of both of them. All I gotta do now is figure out what sine of this thing is and what cotan is, which is just the reciprocal of tan. So let's find the missing side first. Do it the same way you always do. Pythagorean theorem, right? So we're gonna be 3x squared, whole thing squared, plus b squared equals 1 squared, right? So we're gonna square 3x squared. We don't have, I'll say b, and then square 1. So I get 9x squared plus b squared equals 1. Try to get b by itself, so subtract 9x squared from both sides. B squared equals 1 minus 9x squared, square root both sides. So b equals square root of 1 minus 9x squared. And then, that's my b. So that goes right here. So what is sine of that? Sine is SOHCAHTOA, opposite over hypotenuse. So square root of 1 minus 9x squared over 1. So just that. And then what's cotan? Remember, tan is sine over cosine. That's what tan is. So cotan will be cosine over sine. Or taking it back a bit, tan is opposite over adjacent. So we're going to want adjacent over opposite. So adjacent 3x over the opposite square root of 1 minus 9x squared. And that's our answer. That's how we do this problem.